Hello, I'm Bruce Dweck, Chief of the Energy Conservation Division in the Jacksonville Electric Authority at Jacksonville, Florida. Welcome to Part 3 in our 5-part series on constructing an energy-efficient home. We designed this series to help you build the most energy-efficient home at the most economical price. Some energy features are better investments than others. One of the greatest factors determining which features are best is the climate where you will build. The climate in our area is generally hot and humid and extends over the area shown in green on this map. All of Florida and parts of Georgia, South Carolina, Alabama, Mississippi, Louisiana, and Texas. The information in this series is tailored to this climate. The information in this program will cover the major structural components of the home, the floors, walls, ceilings, and how they can be constructed to save energy. Let's begin with floors.
In house construction in the South, there are two basic types of floors, slab and off-grade. A slab foundation is formed by pouring concrete into a form directly on the ground. In off-grade construction, the floor is supported, usually on a foundation wall. Beneath the floor is a crawl space. Off-grade floors need to be air-tightened to prevent air leakage into and out of the home through the many seams, joints, and penetrations. Properly applied adhesives and sealants make the seams and joints of an off-grade floor airtight. A foam caulking or other approved sealant can be used to seal all plumbing, wire, and other penetrations through the floor. Heat flows out of the house in winter and into the house in summer. In order to reduce this heat flow, spaces between the floor joists need to be insulated. When placing the insulation against the subfloor, make sure the fit is snug, but that the insulation is not compressed. Compressed insulation greatly reduces its effectiveness. R value, or resistance value, is a measure of the effectiveness of insulation. The larger the R value number, the better the insulation. In this climate area, R11 insulation is recommended for off-grade floors. Although off-grade floors are necessary in some areas, in this climate zone, slab floors provide an energy benefit because slabs are in contact with the earth. For a few weeks in spring, the slab absorbs heat from the house and helps keep the house cool. In many areas of the country, slabs are insulated around the edges. However, in this climate area, the cost of insulating the slab almost always outweighs its benefits. Three basic types of walls are constructed in this area: concrete block, load-bearing or Norwegian brick, and wood frame. Brick veneer is a type of wood frame construction. One of the most common forms of construction in this climate area is wood frame. Framing forms the skeleton of the wood house. Although most of the space in the wood frame wall is open and able to be filled with insulation, nearly 20% of the wall is filled with wood, a relatively poor insulator. And where you have wood, you cannot have insulation. A 2x4 stud has an R value of approximately 4.5. A 3.5-inch insulation bat has an R value of 11. By eliminating wood that is not structurally important, you create opportunities to add insulation. The first opportunity for improving energy efficiency in wood frame walls occurs with corners and T's. A typical 3-stud corner is constructed with 3 2x4s and blocking. While 3-stud corners are often used, this type of corner, which must be insulated from the outside, often receives no insulation. It is usually covered by sheathing or siding before the insulators begin work. If corners like this are used, make sure they are insulated before they are covered. One way to improve framing efficiency is to construct 2-stud open corners, which allow the insulators to get into the corner after the sheathing is in place. Energy consultant and builder Philip Wimhoff explains.
This is a typical corner. It's made up of 3 studs and blocking. It's more difficult to insulate and leaks a little bit more. We're going to reconstruct this corner over here 3 studs and the blocking. Another way of doing this is to use a 1x4. It provides for more insulation, a tighter corner, and it costs a little bit less.
Another opportunity for improving energy efficiency is in the construction of T's, the post at the intersection of the outside and inside walls. Builder Peter Colson demonstrates.
What I have here are the nailers for a conventional framing T that we use at the intersection of interior and exterior walls. I'll go ahead and put this in place right now so you can see how it works. The studs on either side provide nailing on the interior of the house for the drywall. It also tends to limit the amount of insulation we could force into this wall cavity later. So we're recommending that we omit this particular T and build a one-piece T. And I'll show you what to do, Eric. The one-piece T uses either a pair of 1x4s or a 1x6 nailed to the interior stud. These 1x's provide backup nailing for the drywall, but in no way limit the amount of insulation we can force into the cavity after the sheathing's on.
With this type of T, the insulation can be installed from the inside after the sheathing is in place. Another insulating opportunity which may be overlooked is the header, the framing over the doors and windows. Foam board insulation can be placed between the parts of the header during construction, thereby doubling the R value. Foam board insulation is often used as sheathing on the outside surface of walls. Although the cost is slightly more than wood or laminated paper sheathings, the R value is much greater. A 2x4 wall with foam board sheathing can have a better total R value than a 2x6 wood-sheathed wall and cost less to build, an energy construction bargain.
This is a foam board sheathing. This particular one is phenolic foam. It has an R value of 8.3 per inch. It covers the frame wall.
Foam board sheathing can be used to seal and air tighten the house. For best results, the foam board needs to cover the outer walls of the house entirely. When used for wall bracing, wood panels interrupt the continuous foam board covering. Metal braces can be used instead. Metal braces allow foam board sheathing to surround the house and help create a tighter and better insulated home. This is a compression tension type metal brace and has an end view that resembles the letter T. To install this brace, the studs have to be notched. Then, the brace is hammered into the notch, giving the wall greater strength. The foam board sheathing is placed directly over the brace. In this way, the sheathing surrounds the house entirely. Foam sheathings, which are covered with foil, provide some additional advantages beyond their high insulation value. They reflect heat and are easily sealed. The reflective foil covers both sides. On brick veneer homes, place the more reflective side, the side with no lettering, toward the outside of the building where there will be an airspace created by the brick. When a reflective surface faces an airspace, a partial barrier to heat flow is created. With the framing covered, the builder begins to deal with interior insulation. Paper-faced insulation encourages compressions of the insulation because of the folds in the paper and because it is stapled to the sides of the studs. These compressions can reduce the R value of the insulation by as much as 30%, and compressions create channels for air to circulate inside the wall, reducing the insulation value of the wall even more. Unfaced bats do not have a paper facing, so they are free of compression problems caused by paper. And because they don't have to be stapled, it is easier to fill the wall cavity completely, from front to back and from side to side, so airflow in the wall is kept to a minimum. When insulating around wires and pipes, each insulation bat can be separated in order to surround the wires or pipes completely. Or the insulation installer can cut masonry insulation into patches and place them behind the wires and pipes. When the full-sized bat is installed later, all potential gaps have been filled. An alternative to fitting insulation around wires is to run the wires along the bottom plate of the wall. The insulation rests on the top of the wires. This technique can be used in 2x6 walls and in non-load-bearing 2x4 walls. For maximum energy efficiency, insulation should also be placed behind utility boxes. Open corners and tees can be insulated from inside the house. Use scrap pieces of batt insulation around the windows and doors instead of foam caulks that may expand and harden, making window sash and door jamb adjustment difficult. Ceiling insulation completes the insulation work. The two most popular types for ceilings are commonly called batt insulation and blown insulation. Blown insulation is made up of small pieces of fiberglass, rock wool, or cellulose. Blown insulation costs less than batt insulation, yet it yields a greater overall R value because it covers the wood framing of the ceiling. Blown insulation can be used above most cathedral ceilings. Blown insulation will not slide nor tumble down the slope as long as the slope is less than 412. This means 4 inches of vertical rise for each 12 inches of horizontal run. For ceilings with slopes greater than 412, batt insulation is recommended. Many builders express a concern for quality control when using blown insulation. 2 steps can be taken to be sure that the insulation is distributed evenly and that the correct amount of insulation has been installed. Before the ceiling drywall goes up, reference marks can be painted on parts of the roof trusses. Mark the height of the number of inches listed by the manufacturer, making certain that the marks are visible from the access hatch. During the installation, the contractor or homeowner should count the number of bags or shipping packages used. The manufacturer's literature includes information on the correct amount of insulation for the selected R value and attic floor area. One possible limitation: blown insulation requires room for an installer to work. In areas that are not accessible, batt insulation should be used. How much ceiling insulation should there be? Insulation values of R19 up to R30 are worthwhile, but amounts greater than R30 are probably not a good investment. The use of radiant barriers to reduce heat flow into the house through the ceiling is an idea currently receiving attention. Radiant barriers use reflective foil in a well-ventilated attic to reduce the amount of radiant heat entering the home. Scientific testing indicates that radiant barriers do little to prevent heat loss in the winter, but they are effective for reducing heat flow in summer, if installed correctly over lower amounts of ceiling insulation such as R19. When used with R30 ceiling insulation, however, radiant barriers provide little benefit. Generally, radiant barriers are not good investments if the total installed cost is greater than 20 cents per square foot. By way of comparison, 20 cents per square foot is also the approximate cost of increasing ceiling insulation from R19 to R30. A potential problem for attic insulation is the knee wall. A knee wall is a vertical wall which faces attic space. For example, the triangular-shaped part of a cathedral ceiling often forms a knee wall. The light channels of skylights are also considered knee walls. Insulation will lose R value in these areas if not installed correctly.
Okay, this is the way a knee wall is usually insulated. The insulation is facing the outside and the paper is on the inside. You notice the wood here, the heat moves through the wood also, and a lot of air leaks by the outside between the insulation and the wood. And here we have heat flow that moves multi-dimensionally. It moves out this way as well as out this way. This is a better way of doing it. We put the paper facing on the outside and we tightly seal it along the wood stud. Over here we taped it. The seam is taped. It's very tight this way. We compress the insulation slightly so we lose a little bit of insulation value, but it's much more airtight, which gives us a better benefit. Up here, we've created a dam. It's 8 inches high, so that when we blow the insulation in, it'll hold the insulation up here at this level.
An accessible attic provides several energy advantages. It allows the use of lower-cost blown insulation. It allows future additions of insulation if justified, and it allows ductwork to be examined over the years for leaks. In a single assembly roof, the rafters are made of single pieces of lumber. With the roof deck on top and the ceiling board below, little room remains between the rafters and the very important ventilation channel for insulation. But truss systems can be used instead of a single assembly. A truss system leaves a greater distance between the roof deck and the ceiling board, allowing for more insulation and improved ventilation. If a single assembly roof must be used, install ventilation baffles under the entire roof deck from the eaves to the ridge of the roof. Baffles prevent the insulation from blocking the airstream under the roof deck. This will ensure adequate ventilation, which prevents moisture damage, and full R value of the insulation. Adequate attic ventilation is an important aspect of energy-efficient construction. Air in the attic becomes hot from the sun-heated roof. This heat needs to be removed. A good ventilation system can remove the heat before it enters the house. The ideal ventilation system includes a continuous ridge vent at the top of the roof, plus continuous eave vents at the bottom of the roof near the overhangs. With a gable roof, the ridge vent should travel from end to end. This ridge vent is barely noticeable. Ridge vents, which can be shingled or tiled over, are available. Often, houses with hipped roofs do not have enough attic ventilation. If your house plans call for a hipped roof, use a ridge vent and add 6 feet of off-ridge vent for each hip end of the roof. Ridge and off-ridge vents are more effective for ventilation than either turbine vents or power vents. Plus, they consume no electricity. Eave vents allow the cooler outside air to enter the attic to replace the hot air that escapes through the ridge vent. To be most effective, eave vents should be at least 3 inches wide and should run the full length of the wall. Note the baffle beyond the screen of the eave vent. Baffles need to be fairly long, at least 4 feet. Placed above the eave vents, baffles prevent the insulation from blocking the airflow, and they keep high winds from shifting the insulation. Although many people understand the importance of insulating, few realize the impact that air tightening a home has on energy bills. As recently as 15 years ago, most homes were not airtight. All of the air-conditioned or heated air would leak out of the home to be replaced by outside air several times each hour. Because of this air leakage, the homeowner had to pay to air condition or heat all of the air in the home several times each hour. Now, by employing air tightening techniques, much less air leaks out. This yields great energy and financial savings for the homeowner. In addition, the use of air tightening techniques greatly reduces the amount of air and moisture leaking into the house. In this climate area, moisture is a major problem. Energy Workshop instructor Philip Wimhoff explains how moisture enters the home, using summer as an example.
What are the sources of moisture that ends up inside the home? The first source, 1 to 2 pounds of moisture each day, gets into the house by traveling directly through the building materials, directly through the wood, the drywall, and so forth of the house. The second source, 20 to 24 pounds of moisture each day, comes into the house by way of the activities of the occupants, by bathing, by body water evaporation, by cooking, by plants, and so forth. The third and largest source, 70 to 80 pounds of moisture each day, comes into the house by air infiltration. It comes in through cracks in the building envelope or skin of the house. The 70 to 80 pounds of moisture is actually about 10 gallons of moisture each day through air infiltration.
In order to maintain comfort, moisture must be removed. Air conditioners can remove only part of the moisture, about 55 pounds of the nearly 100 pounds produced each day. This results in high humidity conditions in the home. To reduce this humidity, so occupants can be comfortable, homeowners set the thermostat at a colder temperature than necessary, thereby increasing their cooling costs. A better solution to this problem is to air tighten the house during construction. Air tightening stops the moisture-laden air from entering the house, and in this way reduces the amount of moisture that the air conditioner must remove. Studies indicate that almost half of the air leaking into a house enters through gaps in the walls and ceilings. Practical, low-cost methods are available to prevent this leakage. Remember, initial construction is the only low-cost opportunity to air tighten your home. After your home is finished, air tightening cannot be accomplished at a reasonable cost. Sealing the outside skin of the house is the first task in air tightening a home. Once the foam board sheathing is in place, a high-quality tape should be used to seal the vertical seams. A tape with an acrylic adhesive is recommended for all seams, holes, and tears. The adhesive on this tape will set only if it is rubbed into place. Use the smooth edge of a piece of wood or a burnishing tool. Careful sealing keeps expensive conditioned air from leaking out of the house, and in summer keeps hot, humid air from leaking in. Gaps around windows are a great source of air leakage. Tape the fins of the window to the sheathing to close these gaps. The next step is to seal the sheathing to the foundation wall. This builder has volunteered to show us the wrong way of doing it. He must seal this area twice, the sheathing to the bottom plate, then the bottom plate to the foundation wall. You can avoid having to use a double seal by planning ahead. When you install the sheathing, place it so that it slightly overlaps the upper edge of the foundation wall. If this procedure is followed, you need only one seal. The sheathing is sealed directly to the foundation wall. For off-grade wood floors, seal the sheathing directly to the floor decking. Selecting and applying the right sealant is very important because you will never again be able to access the places that need to be sealed. An oil-based acoustical sealant is a good choice. It is waterproof and sticks very well to virtually all materials. To seal the sheathing to the door jamb, plan to leave a small gap between the sheathing and the jamb to be filled later with acoustical sealant. By applying this method, the seal remains recessed and is protected from damage. Acoustical sealant, unlike an expanding, hardening foam, allows the jamb to be adjusted when the door is hung without breaking the seal. If sheathing is not used for air tightening, a house wrap is recommended. House wraps are plastic films which allow very little air to pass through. Moisture, however, does travel through the material quite easily. The house wrap needs to be installed after the windows and door jambs are in place. In order to reduce the risk of rainwater leaking past the window casement and staining the drywall, flashings should be used. The bottom flashings for windows made from the house wrap are installed before the windows go in. Then, after installing the windows, cover the outside walls, the wood frame, windows and doors with the house wrap. Cut an opening for the windows. The opening should be only slightly larger than the glass part of the window. Make sure that enough house wrap remains to cover the mounting fins of the window completely. Begin at the bottom of the window. Pull the bottom flashing into place and tape it to the house wrap. The bottom mounting fin of the window is also taped to the flashing. Next, lift the flap of the house wrap on the other three sides of the window and apply a bead of sealant to the mounting fin beneath. Press the flap into the sealant to complete the work on the flashing. Next, staple the house wrap to the rough framing around the window. You should also use flashings above doors. Here, black polyethylene has been used for demonstration purposes. Seal the house wrap to the door frames using the same methods shown for windows. Be sure to seal the house wrap to the foundation wall. First, staple the house wrap to the bottom plate of the wall. Apply the sealant at the top of the foundation wall, then press the house wrap into the sealant. This eliminates the need for a bottom plate gasket. Next, seal the house wrap to the top plate, then staple above the seal. Be sure to repair all holes with tape, and when two pieces of house wrap need to be joined, overlap the pieces at a stud and seal the joint with either a tape or a sealant. Another potential area for air leakage is the wall between the garage and the conditioned living space of the home. This garage partition wall should also be sealed. Create an airtight bridge between the foam sheathing of the exposed wall and the dry wall of the garage partition. This is done by sealing the foam sheathing to the wood nailer for the dry wall. Then seal the nailer to the dry wall. Be sure also to seal the dry wall to the top plate, to the slab, to the door jamb, and to the electrical service box. Use the same techniques as those suggested for sealing foam board sheathings on the outside wall. Use a water-based acoustical sealant whenever the sealant will contact drywall. Use an oil-based acoustical sealant for all other seals. By applying these air tightening and insulating methods, you should be well on your way to an energy-efficient home.
There are opportunities for savings and energy efficiency in almost every facet of the construction process. Foundation construction, framing, insulating, and air tightening. Some of the air tightening techniques may be new to you, but these are some of the most effective measures you can take to ensure energy efficiency in your new home. In our next program, experts will answer some very important questions about vapor barriers. We'll also finish air tightening and insulating and cover moisture control and indoor air quality. Please join us next time for Southern Home Building Blueprint for Energy.